Sega here, and for this video, I'm going to help us through Experiment 2A and Experiment 2B. Depending on what your group has been assigned to do, you're either going to be studying the mass versus acceleration or the net force versus acceleration. But in either case, you're using the same experimental data, so I want to make sure that you can use this pivot appropriately. Okay, so a thing to point out here is in this video, or in this set of videos, we have a bunch of different fan carts. Those fan carts are going to be pulling, stretching a spring, but then the spring is cut and moves along this track. All right, so what you're going to have to do is you're going to have to vary the mass and force by hitting change. And depending on what your experiment is, either you'll have constant force and vary the mass, or constant mass and vary the force. So let's say we just keep it on this original setting here, so it's easy to work with. Here's how we make our measurements. I'm going to rewind my video, and we can actually measure force by using this tool in the top right. Notice that there are two rulers, a ruler in centimeters, which we're going to use down on this track, and a ruler in newtons. Woo! Because the people who made this video know about this spring, know things about this spring, they can figure out how to calibrate distance to actually relate to the force of the spring. So see how my spring is at this equilibrium length right now? I'm going to set my Newton scale right on the edge of my spring, just like I'm setting my meters or my centimeter scale right to the edge of my fan cart. Now, if we let this go forward, I see that as the fan cart turns on, it's going to stretch the spring, and it stretches the spring all the way out to here in the top view. The spring has stretched to a distance that correlates to 1.5 newtons. If you're measuring different forces, you would change the fan force and actually be able to figure out how many newtons that puts on the spring, and that would be equal to the force of the fan. So one more time, in order to measure the force of the fan, I would put my Newton ruler, my Newton measuring ruler, to the original length of the spring, and then measure its value when it's to its full extension. This reads 1.5 newtons at its full extension. Now, notice that that moved my fan, so I'm going to have to adjust the position ruler. And what I'm going to do is I'm going to start the timer when I see it start moving. But this can actually be super accurate. So what I'm going to do is I'm going to inch this forward frame by frame until the string gets cut. I'll be able to see the string getting cut, and I would count this as my 0th frame. So once again, string is solid, string is cut. I would pull out the timer and call this the 0 second of time. So now when the cart moves, it has just the force of the fan, the 1.5 newtons from the fan, acting on it to the right. The spring is gone, it's not holding it back anymore. And I'm going to time how long it takes to get to 0.5 meters or 50 centimeters. This is the distance we're going to use for the whole lab. And if you're studying mass, you'll see why 50 centimeters was the distance we chose here. So I would record this as 0.733 seconds. A thing to note as you're doing this experiment is as you enter your data, lock answer and continue. As you enter your data, if I put in my time of 0.773 seconds, it'll automatically calculate the acceleration for you. But this only works if you're using your 0.5 meters or 50 centimeters as the distance it travels. All right, guys, so once you're all done, you're going to end up with mass, time, and acceleration, or force, time, and acceleration, and you want to be able to plot those numbers. So I'm going to check out my horizontal graph over here. When you go to plot, you would put your dependent variable on the y-axis. My dependent variable was acceleration. Your independent variable on the axis, that's force or mass. Right? Then it will plot it automatically for you. Actually, it will do one other thing automatically for you. Guys, it will automatically tell you what graph this is. Okay? So, from here, curve fits, and you can select which fit best suits your data. You do need to have as many data points as possible in order to make it accurate. Then when you get to the very end, after you do interpreting graph, then you're going to make your presentation together with your group. All right, let me know if you need help. Best of luck. Bye.